this video, we will talk about graphing quadratic functions. Quadratic function, remember, is a function which has the x squared term. So here f of x equals a times x squared plus bx plus c. And the graph of this quadratic function is called a parabola. So here we see two different parabolas. The first one opens upwards and the second one opens downwards. And what determines this is the first coefficient. So if the first coefficient a is positive, the parabola opens upwards. And if the first coefficient a is negative, the parabola opens downwards. We will talk about some properties. So these are the x-intercepts. And remember, at an x-intercept, the y-coordinate equals 0. So all these x-intercepts have y-coordinates equal to 0. So this is how we can find the coordinates of the x-intercepts. So since y is given by f of x, so y values are found by plugging in the x values to the function, and since our function f of x equals ax squared plus bx plus c, so if we set this equation equal to 0 and solve this equation, the values we find will be the x-intercepts of these graphs. So we might have two x-intercepts. In some cases, we might get just one x-intercept or no x-intercept. So the other thing we will talk about will be the y-intercepts. So in these two graphs, we have the y-intercepts here, where the graph intercepts the y-axis, and how we can find it. So realize that at a y-intercept, in this case, the x-coordinate is 0. Therefore, if we plug in 0 to our function, then we can evaluate the y-intercept. So the value of the y-intercept can be found by evaluating our function at 0. And what do we get when we plug in 0? We have a times 0 squared plus b times 0 plus c. So the first two terms cancel out and we get just the last coefficient, c. Therefore, we can say that the y-intercept equals the value c. The next thing is the axis of symmetry. These parabolas are symmetric around this line, which is called the axis of symmetry. It acts like a mirror. It divides the parabola in half. And the equation of this axis of symmetry can be found by this formula. So x equals negative b over 2a this formula can be used to determine the equation of this line. And realize that since this is a vertical line, the equation is of the form x equals a constant number, where that number is equal to negative b over 2a. And one last property is the vertex of the parabola. So the vertex sits at the axis of symmetry. Therefore, the x-coordinate of the vertex equals negative b over 2a. And we can find the y-coordinate of the vertex by plugging in this value into our function f. So we will see some solved problems and we will see how to locate these points and then how we can connect them to graph a